Welcome to the second lesson in Session 8 on equation building. In Lesson 6.2, we learned how to use the zero product property to find solutions of a given equation. For example, in the equation x squared plus 3x minus 18, we would first factor the trinomial and express it as the quantity of x plus 6 times the quantity of x minus 3 equal to 0. We would then apply the zero product property, which would allow us to state that either x plus 6 is equal to 0 or x minus 3 is equal to 0. And that would produce solutions of negative 6 and positive 3. In this lesson, we're going to reverse that process and build the equation given the solutions. For example, I'm going to ask to write an equation that has 7 and negative 3 as solutions. Well, if 7 and negative 3 are solutions, we could package that up as the quantity of x minus 7 times the quantity of x plus 3 equal to 0. And now if we distribute those two binomials, we get x squared minus 4x minus 21 is equal to 0. So we've created an equation that has the solutions of 7 and negative 3. In the next examples, we need to find the lowest degree polynomial equation with integer coefficients that has the given roots. As we learned in the last lesson, it's important to understand that irrational and complex solutions always come in pairs. So in the first example, we know that x is equal to negative 2 and the square root of 5. So we have to build an equation with integer coefficients that has those roots. Since the square root of 5 is given as a solution, we know that its opposite will also be included in the solution set. So square root of 5 is included in the solution set. The negative square root of 5 has to be included in the solution set as well. So now we build binomials with these solutions, x plus 2, x minus root 5, and x plus root 5. Now when I multiply, I'm going to multiply the irrational binomials first, giving me x squared minus 5. Now when I multiply the x squared minus 5 times x plus 2, I get x to the third plus 2x to the second minus 5x minus 10. So that's the equation. It's the least degree polynomial equation with integer coefficients that has the given roots. We follow the same process for the next equation. We're given that x is equal to 4 and negative 3i. And since negative 3i is given as a solution, we know that its opposite will also be included in the solution set. So x equals 4, negative 3i, and positive 3i. So my polynomials are going to be x minus 4, x plus 3i, and x minus 3i. And just like in the last example where we multiplied the irrational binomials first, in this case I'm going to multiply the complex binomials first, giving me x squared plus 9, and then I'm going to multiply that result by x minus 4. So the equation we're looking for is x to the third minus 4x squared plus 9x minus 36. And in the third example, we're given that x equals negative 4, 3, and 1 plus I. Since the 1 plus I is given as a solution, we know that its conjugate will also be included in the solution set. So in addition to 1 plus I, we also have to include 1 minus I. So now the binomials that we build are going to be x plus 4, x minus 3, x minus 1 plus I, and x minus 1 minus I. Now first we have to simplify before we multiply, and that's going to give us x squared minus 2x plus 2 when I simplify and multiply the polynomials containing the complex numbers, and x squared plus x minus 12 when I multiply the x plus 4 and the x minus 3. Now we're ready to multiply the two trinomials together, and that gives us a result of x to the fourth minus x to the third minus 12x plus 26 minus 24 equal to 0. And that wraps up this lesson. Good luck on the quiz, and please email us if you have any questions.